and then to understand how these three vocabulary words or how outliers impact different concepts about the line. So what we're going to be talking about first is the three vocabulary words we're learning: outliers, influential points, and the leverage. Okay, outliers, influential points, and leverage. And then the other thing is oh, that's even in the wrong place. Okay. The other item is that we're going to also go over some computer printouts. Okay? Because I told you guys, and we learned about this most common computer printout called Minitab. There are some other software programs out there. And so what I want to do is take this data from Minitab and see what it looks like in a different computer program. All right. But first, let's learn these vocabulary words. So, the first one is outlier. We have a sense of outlier. We kind of understand what that concept is. There technically is no straight out numerical number for what makes something an outlier. Okay? However, since we have recently talked about standard deviations of the residual, we're going to reference an outlier in that terms. So, for example, if I draw this graph right here, what type of graph is that going to be referenced? Good. That's going to be a residual plot. Okay, we know that's going to be a residual plot. And so, if I have a residual plot of data, then I'm going to have one standard deviation of the residual up and another standard deviation of the residual up. And same thing with down. So, really, what happens is an outlier comes from being more than two standard deviations away from what is predicted. More than two standard deviations away from predicted. So, in a sense, you're going to have an outlier if it's way here or here, okay, because it's, in a sense, more than two standard deviations away from the prediction line. Okay, so that's what's happening for definition of outlier. Next, this thing called influential point. This, honestly, in my mind, is a little backwards of a definition because it says if omitting a point. So basically, if you take a point away and it has a very big impact on the equation of the line. So it significantly impacts. Unfortunately, we don't have a definition for how much is very different. Okay, so we don't know that exactly, but we know that omitting that point, taking it away, if it changes the equation of the line quite a bit, then that point is called influential. All right, and so let's actually stop right there for just a moment. I want to do a couple demonstrations. So if we look here at this, okay, we've got some points. What we might find happens is if I take this and I move it a lot in this direction and this direction, it is changing the equation of the line. I would probably consider this changing the equation of the line just slightly. Do you see that? It's moving it some, but not a whole lot. Now what happens when I do motion of this point out here? What's this going to do? Yeah, do you see how much more power and potential a point that is way far out has to drastically impact? I don't know why that's all moving. To change the equation of the line. So to drastically change the equation of the line. Okay. As opposed to this one in here. I can move it a lot, but it's still not changing the equation very much. All right. This potential, this being way far out in the x direction is called leverage. You have a lot of leverage if you have the potential to make a very quick and large impact on the equation of your line. So a point way far out here is considered high leverage. You know what? This point out here is called having high leverage even if it's exerting that influence. Okay, so look at this right here. This point has high leverage right now. Is it changing the equation of the line? It's not. It still, though, is called high leverage. Okay? So this point is still called having high leverage because it has the potential to very easily exert quite a bit of influence. Okay, so that then takes us here to this. High leverage means that you are really kind of, your x value is far away from the mean of the x's, the middle of most of the x's. Then you have leverage. High leverage pulls the line close, and so then you have a large effect on the line. Sometimes the slope is completely determined. The slope in the y-intercept changes because of that. So let me show you one other little interesting demonstration, and then we'll go to doing some of these problems. Let's just say that, let's say I have some points that are pretty random, and that there's really, is there much linear correlation going on here? No. If you saw this, you'd probably say there's, actually, look at the R value right here. So there's not much of a linear correlation. Okay. Now, watch this. If I take one of these points, watch this one point. I'm going to take it and pull it way out here because it has high leverage. Let's see if I can get that. Okay, it has high leverage. And watch this. I'm going to pull it right here. It almost makes it appear as though there is what? Yeah. Look at this. This is now a moderate, a fairly strong negative linear correlation. So this one point being down here is making it seem as though there is a relationship in this data, and there really is not. It's just that it's taking nothing and pulling it towards it, so it takes no correlation and changes it into one. Okay, so something interesting to think about. All right, so let's go through these little definitional things. So here we go. For each one of these pictures, I want us to first use our crayons. Okay, not your crayons. Okay, not your crowns, whatever those are. Those are things that go on multiple kings' heads. Crowns. These are crayons, and we're going to draw two lines. Yes, they're crayons, but some people say crowns.
C-A-R-A-N.
Who says crowns? I mean, come on. Yeah. My little 6-year-old says crowns, and I'm like, where do you get that? I have always said crowns. All right. Okay, you guys ready? Here we go. I want you to pick a color, and I want you to say that you are going to draw the, actually I'm going to do this in green because it'll coincide with the computer. So I'm going to do the least squares regression line with the point in. Okay? And then in another crayon, I'm going to be drawing a least squares regression line with a point out. Honestly, I think that was the easiest one to draw, so let's actually start with that. Let's draw the least. So on this first item, what is your question of the line going to look like with this outlier, with this point that's way out there? You can probably draw that in. You can see it's nice and straight, and it's actually probably going to go through that point out there. All right? Well, what is going to happen? What is going to happen if I put this point right here in? Is it going to change the equation of this line much? No, not really. It's pretty much going to still look like that. So when you put this point in, it's still pretty much going to look the same. Okay, let's do the next one. Okay, first, pretend like this weird point is not there. Draw a line. Okay? Alright. Now, I'm going to go, and this point is in here. So when that point gets in there, what's going to happen to this equation? Yeah, it actually is going to kind of pull this down. In fact, I'm going to use my little program here and kind of demonstrate that. So let me get this set up here. I know. I think that I had that line kind of drawn in there from past years. It's all right. Okay, here we go. So here's the line. Now watch what happens when I pull this down. Let's see how much. Oh, it has leverage, right? Doesn't that one have pretty good leverage? It's out here. But it's, look at that. Boom. Look what happens. It really is changing. I mean, the slope is even changing. Furthermore, you want to know the weirdest thing? And we'll talk about this in a second. The strangest thing is this. Let's consider the residual here. Look at this. And here. Okay, listen. See this green line? Because this green line got pulled down, it almost makes this point not even seem like it has that much of a weird residual. This residual is about as large as this residual, just in the opposite direction. Isn't that weird? So what happened is this point was so influential and it pulled the line so much to it that it almost makes it not seem as though it has a big residual. Okay, we'll talk about that in a minute. Let's do this last one. Draw your blue line without that weird point. And now, what do you think what's gonna happen when this point is in there? Question, what kind of leverage does this point up right here have?
Not as much as the middle edge that goes out.
Correct. Remember that the definition of leverage is a point that is far out in the x direction, far away from the mean of x. Okay, that's the definition. This point right here, it's actually not too far away from the mean of x, so it really has little to no leverage. I mean, it's not considered high leverage. So let's take a look at what this might seem like. Okay, here's our data. Okay, and then I'm going to take a point here. Here it goes. I'm going to pull it up. Even when I pull it way up, does it really significantly impact this line? Not particularly. It does have a small amount of change, but it is not a significant impact. Now, I would like to say this. I believe that this point right here is a little bit to the left of the middle. So in essence, you're kind of going to be pulling up, this rear part, this butt of the line, this kind of rear section of the line. So I think it's going to have a little bit more look like this when you draw your green line. So let's do that. So let me draw my, here is my line when you take that point into consideration. Okay? All right. Here we go. Now let's answer these questions. Number 1. Tell whether the outlier points have high leverage. Does this outlier point have high leverage? Yes, it does. It is far away from the mean of x. High leverage. Is it exerting its influence, by the way? It is not currently exerting its influence, but it has the potential to be very influential. It's not currently being that way. Does it have a large residual? No, it doesn't. It's small to no residual. Alright. How about, is it being influential? The definition of influential means taking that point away makes a large impact on the equation of the line. So is that true? That means going from green to blue. Is there a big change in the equation of the line? No. Okay? All right. 2. Now, I'm going to have to demonstrate this one. This one actually is a little more counterintuitive. So it doesn't kind of seem to make sense with common sense. So let's talk about it. Number 2 questions are this. If you remove the point, that means you're going from green. In my case, I'm going from green to blue. I'm going in the data to out of the data. Would the correlation, what's that referencing? Good, the R value, the linearity, okay? Would it become stronger or weaker? That is our question. And before we answer this one, because I have, most people intuitively think that removing it makes the correlation smaller because you see yourself as taking away this outlier. But it's in the X direction, so that and it's on the line. So let me give you a demonstration. So here we go. Okay, see this right here? This is our high leverage point that is in line with the data. And look at the correlation. Yeah, that's good and strong correlation there. And then watch what happens when it moves in. So here we go. So if this point were actually a point in here, look at that correlation. It's 0.98. So the reality is this point actually got what? Weaker. It did. I mean, the correlation got weaker. Okay? So here is why. Here is the reason why. So I want you to think of it this way. If all you have is this information right here, then you know that your linearity is going to be occurring from here to here. So you have linearity confirmed in this section. Okay? But if you have this point in here, then in a sense, that is extending the region that you can count on there being linearity. So the fact that something out here occurred and it's still in line, then I now feel fairly confident that I've got linearity in this entire region. So that's strengthening the correlation. Does that make sense? All right, I see nods. Okay, I think it is. So that's strengthening that correlation by extending its range of strength. Good. Next. Oh, wait. Okay, so let's answer this. So if you take away the point, the correlation gets weaker. Very good. If you take away the point, the correlation gets weaker. I'm not going to explain it because I kind of did there verbally, so we'll just kind of get that part there. All right. Number 3. If that point were removed from the data, would the slope of the regression line increase or decrease? Actually, in this case, it's going to do neither. It's really pretty much going to what? Pretty much going to be the same slope. All right, very good. Let's do that. Same questions for the second one. Here we go. First question. Does this point have high leverage? Yes, it is far out in the X direction. So it does have high leverage. Is it exerting its influence?
Yeah.
It is. So the question is it going to have a large residual?
Yeah.
I think it's, you want to say that, yeah, it is, because it's going to be far away there. Yeah, you're going to want to just kind of watch it. It's difficult, I think, to tell in this case because it's pulling the line towards it. So it almost actually has about the same residual as any other thing. So that could be very deceiving. Honestly, I would have to look at the way you drew your line, because your line might have looked like, your line might have just been like that, and then, well, I don't know. See, then it's got a high. Then this has a big residual, but how does that residual compare to this residual? They're still about the same, yeah. So in essence, what happens to this residual relation to this residual? It's actually pretty comparable. So that messes things up. It's about the same residual. Hold on. About the same as other points in the data. So, yes?
But even though the rest of those numbers are still clustered up there, wouldn't it?
I know, wouldn't you think?
But it's like the waves and the.
I'm sure that your brain should say, hey, you know what? This one is like in a way different place than all the other ones. It's the only one with a large negative residual, and the other ones negative, and the other ones have. Oh, wait, I don't know. That's not true. This one was a negative residual. This one's a negative residual. So if you looked at a residual plot of this, you're going to see something like this. You know? See? So, I don't know. Anyways, see? It was so influential that it made it look as though it didn't have much of a residual. Next question, is this point influential? Yes. Is its removal impacting the line? Yes, it is influential. All right, question number 2. What do you think removing that point does to the correlation? Good, good. Removing that point strengthens the correlation. Okay, because then the remaining points are more closely clustered on the line. Okay, now, let's see here. Let me put my lines back in here. Alright, so with the point, I have this green line. When I remove it, it becomes this blue line. So does the slope increase or decrease? Yeah, pretty much it's increasing because this slope was this way, which is a negative slope, and then it is now turning into a steeper positive slope, so it's an increase. Okay, so that slope is increasing. So what I want to do then is let you try this on your own. Brent, let you do this one right here. I'm going to come around and do some stamping on your homework while you all go through all of the problems, and then we'll check those.
Go Bearcats!
It is not crowns. Frowns.
Round.
All right. Let's see how you did on this one. Here we go. Okay. Number 1. Does that point have high leverage? It does not, because it is not far away from the mean of x, so it does not have high leverage. Then the next question is, does it have a high residual? Gosh, I don't know. That's kind of debatable because it actually still is probably higher than these. I mean, it's pretty close. I don't know. Okay. I'd say the residual is just, I don't know. I probably just have to look at your particular graph. So, in some cases, yours may end up being a different answer on that because you might have a slight bit different line, which then creates a different answer. So, I don't know about that. Okay? Mine, it doesn't really seem like it's much different, so. Next. This is, I don't know. This is residual, I don't know. Because I have to look at your picture.
You put IDK in there?
Yeah. I have to look at your picture. Which, your picture would be kind of scary to look at. Right?
At least you're looking at it.
Okay. Next question is, what's the next one? Oh, influential. Is this one considered influential? Technically, what we would say is not influential because, see, it did not really change it a lot since it does not have high leverage. So we would be more inclined to say that this is not an influential point because it's not going to change the equation of the line a whole lot. It's not. See, this one even changed the direction of its slope. And that's crazy amount of change. This one was just probably slight difference. Okay, the second question. What about the correlation? When you take that point away, what's going to happen to the correlation? It will get stronger because they are more clustered around the line. Number 3. Okay, so I got to look at my picture. We're going from the point in the data set, which is the green. So go from the green line to the blue line. The green line to the blue line. So what happens to the slope? It is getting steeper. So think about it this way. The blue line has a steeper slope than the green line. So therefore the slope is increasing because it is getting steeper. Now, this next page is an activity that we are not going to do because this little demonstration does as much, if not more, than that little activity, so we are skipping it. So the next thing is an example of more computer printouts. This will be just a quick go through and look at these different software programs. I have already shown you Minitab, so let's actually look on the second page first. A few days ago, we learned about the most common software analysis program, Minitab. And so, where in this picture are the y-intercept and slope located? Good. Constant is the y-intercept. Bismarck is the x variable, so therefore 0.74077 is the slope. Very good. This 0.02349, what is that? Standard deviation of the slope. Very good. This number here is an S value, and that is the standard deviation of the residuals. Now, I want to give you an example of how you would write out an interpretation of that. So, let's kind of remember what this is about. Okay, first of all, this is a problem. Here is your data. You are attempting to predict the temperature in New York from the temperature in Bismarck. Okay? So, what we're going to do then is know that if we have a residual plot, then this line right here, what does this line right here represent in a residual plot? What does this represent in the residual plot?
Predicted.
Not actual, but predicted. Very good. So this represents the predicted, and in context, this is going to be the predicted New York temperatures. Okay? All right. Here's the deal. The standard deviation of the residual is 1.75. So that means if I go up 1.75, that's one standard deviation up. That's 1.75 degrees. And then two standard deviations up would be 3.5 degrees. And then going down, okay? So where would a data piece be considered an outlier? More than two standard deviations away. So what's happening is if I have an actual temperature that is more than 3.5 degrees outside of the predicted, then that would be considered an outlier. So that is how you're going to write for interpretation. You would say this. So here we go. If an actual temperature in New York is more than, let's say plus or minus 3.5 degrees away from, I guess probably Fahrenheit, I don't know. Away from the what? Okay, good. Away from the predicted temperature. Okay, then that temperature is an outlier. So that would be a good way to interpret, you know, what this is meaning for us. Okay. Additionally, the other information we're interested in is that the r squared is 99. Okay, so let's go to the front where we have another computer program called JMP-IN. I don't know if they call it Jump In, but anyway, there it is.
Sounds like a fun.
I know, it sounds so fun. Okay, so first, this is the same data. This is still the Bismarck and New York information. So here we go. I'm going to move my hand along this. We're going to say hot and cold. Tell me where the equation of the line is going to be found. Okay, you ready? Right. I'm now what? What am I? Hot or cold? Where's my hand? Hot or cold on the where the information is located? Still cold. Okay. Where am I?
Hot.
Warmer.
You're hot.
What? I'm getting warmer, and then
Now you're on.
there we go. I am on fire. Okay. So here is our intercept, and here is our slope, and right next to it is our slope of the standard deviation. Now I am not positive, but I think this might be the standard deviation of the residual. I'm not sure. Because I'd kind of have to think about this definition for a little bit, but that's the same number, so it might be. And then, of course, here we have the r squared, okay? So what I want you to do is be able to skim through the information and kind of be able to filter out the other data that is not essential to what we use. All right, let's do the last computer printout, which is called Data Desk. Yes, sir.
And how and when and where do we find these?
Okay, these are computer programs that you will be presented with printouts of in this course. And so you need to be able to identify the information. Now, in real life, where you use these would be in your occupation, if you were a business analyst or something. Anyway, that's something that's using prediction, sales, and different things that are coming out.
But like, is it just if somebody buys it, you just use it like Microsoft Word?
Gotcha. So then typically what happens is a company decides which software they're going to use, and then they're going to go send you to a training on, you know, these different, whatever software it is that they chose. Yes. Okay? All right, so here's Data Desk. Let's find our information. First, we see, it's nice. They tell us that the dependent variable is New York, so there we go. That's nice. Look down here. Here is our y-intercept and slope. This right here is the standard deviation of the slope. Good. And here is the standard deviation of the residuals, and then here's your r squared. So you can kind of filter through the rest of the information that you do not need. All right. Now, on your, oh, that's not correct. On your homework, okay? So on your homework, let's pull that up. You basically are going to be doing some of the very same problems that are similar, okay, in process. If I can get this minimized, but no. Okay, so on your homework, first page has the same kind of pictures where you're going to be going and doing those same questions. And then I have a couple of chapter 7 and 8 extra practice stuff. I don't know what I'm doing with this. This is the answers to the homework, so boom, there you go. So now you can go back through that and find it.
Can you
This
email me
is
that
what
link?
I am looking for right here. Here we go. Yay! Okay. There we go. There's your thing. You know what? I've had people ask me this. They don't understand what this is saying. It says, in what way is the point unusual? And so that's kind of a lead-in question. More specifically, does it have high leverage? So really, you're just answering these things right here. Okay, this is just a lead-in question to that. Okay, some people kind of were confused on it. Next, then you start some chapter 7 and 8 questions. Okay, this is still the residual plot stuff. Here's some other questions about correlation. And then here's that stuff where you are using the standard deviation of x, standard deviation of y, and finding the equation of line. That's it. Okay. So you guys will have that. That will be the end